Third problem, we've got a couple of functions here we want to take derivative of. To do both of these, I need to write them as x to a power, then I can use my power rule. So this first one, I've got the derivative of 2. This will be written as x to the 1/3. That's what a cube root is. And then the second one, I'll write as x to the -2. And so when I do that, now I can use my power rule on each of these. This is going to be 2, and then the power rule says take the 1/3 out in front and reduce the exponent by 1. The second one, same thing, so this is 2 times. Don't mistake that for 2 and 1/3. Next one is plus, take the -2 out in front, and then reduce the exponent by 1. So simplifying each of these, I'm going to have 2/3 x to the 1/3 minus 1. Well, that's 1/3 minus 3/3, so that's going to be x to the minus. My pen is smearing here. Let me try again. X to the minus 2/3. And then over here we have minus 2x. And again, it's minus 2x to the minus 3. Now, I'm going to get rid of negative exponents because we know that that's one of the steps in simplifying. And so to do that, I'm going to drop this in the denominator. There's already a 3 in the denominator of this one, so it's going to be just a 2 in the numerator. And then in the denominator, we're going to have the 3 along with the x to the 2/3, becoming a positive now, 2/3. And this other one, only the x drops to the denominator, so I'll still have my 2 in the numerator, and then that x becomes x to the positive 3. And then one more step, we got 2 separate fractions, so I need to combine those as a fraction with common denominator. Well, the common denominator, they both have x to a power and a 3. The biggest power is x cubed, so I'm going to have to multiply this one by something to turn it into a cube. Well, if I multiply it by x to the 4/3, that'll give me, you add the exponents and you get x to the 6/3. So this one's going to have to be multiplied by x to the 4/3. It's hard to read, but it's doing that weird thing again where it's dragging x to the 4/3. Get rid of that. Not 3/4, but 4/3. Okay, so I'm going to multiply top and bottom by that. Can't really read this one, but that says x to the 4/3 in this one. That's not going to be any better. This one needs a 3 down here, so I'm going to have to multiply this by 3 over 3. Okay, so when I do that, this becomes 3x to the 2/3 plus 4/3. And that 4 turned into a 9, but it's not. It's still a 4/3. That's really annoying me. Why it does that, I don't know. But there it is. When I multiply, I get 3x. Add those exponents, you get 6/3, but that's 3x cubed, and there's 3x cubed. So this is going to have a denominator then of 3x cubed, because that's the common denominator. And then the numerator is just going to be these two, so I'm going to have 2 times that, 2 times x to the 4/3. That's this first term, minus 3 times 2, which is 6. And then the only other thing I could do here was factor out, would be to factor out a 2. So I'm going to factor that 2 out. And I get x to the 4/3 minus 3. And that's all divided by 3x cubed. So that's as far as I can simplify it. Nothing else really happens up here, so I'm just going to leave it like that. All right, number 4. This time we have a quotient, and we want to find the derivative. And so I know that dy dt is going to equal the derivative of the top. This is all with respect to t, so I'm just using the right notation. So it's the derivative of the top times the bottom minus the derivative of the bottom times the top and then that's all divided by the bottom squared. And so doing these derivatives that are here from the quotient rule, I get derivative e is e times t squared. Derivative t squared using the power rule is 2, and then reduce the exponent by 1, so that's going to be 2t to the 1 times the e to the t, and that's all divided by t squared squared, which is t to the 4th. And then to simplify this, I can factor out a t and an e to the t, so I'm going to do that. I'm going to factor out t along with e to the t, and here's what's left. In this first one, I'll just have a t left. The second one, I'll have 2. That's divided by t to the 4th. And I can cancel one of these t's, so I do need to do that. This will give me e to the t times t minus 2 divided by t cubed. And there's my fully simplified derivative of that quotient. And then the last one says to find the equation of line tangent to this thing when x is 0. So I need the slope and I need a point. So let's start with the point. The point is going to be what I get when I plug 0. That's going to be my x coordinate. And when I plug it in, that's going to give me my y coordinate. So let's do that. That's going to be 0 for the x coordinate. And plugging this in, you're going to get 0 plus 1, which is 1, and sine of 0, which is 0. So you are going to get 0 for the y coordinate. Now to find the slope, because that's the other thing I need, that's going to come from my derivative evaluated at 0. So in this case, let's take our derivative. I'll get f prime. Let's do just the general derivative first, then we'll plug 0 into it. It's going to be a product rule. It's going to be the derivative of x squared plus 1. It's the derivative of the first. Times sine. So the derivative of the first times the second. Plus the derivative of the second, which is the derivative of sine, times the first, times the x squared plus 1. All right. It's x squared plus 1. All right. Taking each of these derivatives, then this derivative is going to be 2x plus 0, because derivative of 1 is 0, so that one's just going to go away, times the sine x that was there from the product rule. So times sine x. And then the derivative of sine, which is cosine. I'm having to write real slow so it doesn't drag. And then that's times the x squared plus 1. All right, that's my derivative. I don't really have to simplify this one because I just need the slope when x is 0. So I can leave it in this general form. It's really not going to simplify much. I just need to plug 0 in. I'm going to do that. I'm going to get 0 here and 0 here also. And then, so I'm going to have 2 times 0, so that's going to make this whole term 0. So we'll just get rid of it. And then cosine of 0, which is 1. And then 0 squared plus 1, which is also 1. So I get a slope of 1. So it turns out that I have the line with slope 1 passing through this point. Well, that's going to be, the equation is going to be y minus the y coordinate equals the slope x minus the x coordinate. That just ends up being y equal x. Y equal x. So that was what I was asked to find, was the tangent line.